Hello, everyone. Welcome back. We are now on to part 2 of our discussion of titrations. And in this part, we are going to work on understanding the equivalence point of a titration. So, the equivalence point of a titration is when enough strong base in our example, or strong acid in our example, has been added to react with all of the weak acid or base. In our example, we have a weak base. And so this means that we have, in the example that we've been walking through, we've been working with the acetate ion plus HCl. This is a reaction that occurs, and the products of this reaction are acetic acid and chloride, because this is my acid, my HCl is my acid, my acetate is my base, and remember how base takes proton, creating acetic acid. So this reaction is a single arrow. This is not an equilibrium. This is a reaction that goes to completion. And this is a key point. When a reaction goes to completion, it means that we are working with stoichiometry. And so the equivalence point is when both reactants, so both of these guys, are limiting reagents. Another way of thinking about this is that we have added enough acid. So in this example, we have HCl in the burette, and down here in the flask, we have acetate. At the equivalence point, we have added exactly the amount of acid required to react with all of the base. Whoa, what's happening here? So one thing that we can predict about the equivalence point is the pH. And so in this example, we want to determine the pH at the equivalence point of a titration of 10 milliliters of 0.5 molar sodium acetate with 0.3 molar HCl. And so that means that in my burette, I have HCl, and in my flask, I have 10 milliliters of 0.5 molar sodium acetate. In our previous video, we found the amount of HCl required to reach this point. But we also talked about how in this reaction we have HCl plus our, let's back up, plus our sodium acetate reacts to form NaCl plus acetic acid. And the equivalence point is predicted to occur when 16.67 milliliters of HCl is added. So the first step of these problems is to determine what is in solution at the point of the titration that you're interested in. And so step 1 is really what is in solution. And so to do this, we have to think about our titration reaction. So we have HCl plus NaCH3CO2 goes to form NaCl plus CH3CO2H. And what we have to do is we have to figure out what we are starting with. And so so that we can do stoichiometry, remember we have a single arrow. So this means that we need to do stoichiometry. And so to do this, I make up a table. And my table for this one is initial final. And so initially, and in this, I'm putting moles into this table. And so to do that, I have to convert my volumes and my concentrations to moles. And so initially for the HCl, I have 5.00 times 10 to the minus 3 moles. And hold on, I'm going to take a step back. Not initially. At the equivalence point, when I have added my 16.67 milliliters. So this we found from 16.67 milliliters, converting to liters and using the concentration of the HCl. The sodium acetate, we're going to do the same way, and we find that we have 5 times 10 to the minus 3 moles of sodium acetate. Sorry about that. We don't care about the NaCl, and at the equivalence point, initially, we have no acetic acid. So this is thinking about exactly what we have mixed together. We've taken 10 milliliters of our 0.5 molar sodium acetate. And we have added 16.67 milliliters of our 0.3 molar HCl. So notice that these have the same number of moles. This is the definition of the equivalence point. So, what we can do now is think about what happens with this reaction. Since this is a one-to-one relationship and they both have the same number of moles, they're going to react so that there is nothing left of either of these. And there's 5 times 10 to the minus 3 moles of acetic acid in solution. So, we have now figured out what is in solution. So, at the equivalence point, what is in solution? The solution contains just acetic acid. Now, acetic acid is a weak acid. So now, step 2 is going to be to find the pH of the solution. So as we work through these titration problems, we are going to be seeing how all the different ways that we can find the pH of solutions. In this example, we have acetic acid, which is a weak acid. So I have CH3CO2H in solution, that's with water, which forms an equilibrium reaction and we find the pH of the solution with an ice table. Now, in ice tables, we use molarity, which means that I am going to have to find the molarity of the acetic acid in our solution. So I'm going to zoom back out and make sure I know what we have. Okay, so we have 5 times 10 to the minus 3 moles divided by a volume. Now, our volume at the equivalence point, I'm going to back up here. Our volume at the equivalence point is going to be our 16.67 milliliters of HCl that we added, plus our 10 milliliters of sodium acetate. So our molarity is equal to moles divided by liters, which is going to be 5 times 10 to the minus 3 moles, divided by 26.67. Whoops, I got to put that in liters. 0.02667 liters. And so the molarity of the solution is 0.1875 molar. So I can use this in my ice table. And initially, I have none of this. So that means that my change is going to be minus x plus x plus x, 0.1875 minus x, x, and x. And this is described by a Ka is equal to x squared over 0.1875 minus x. And so my Ka for acetic acid is 1.8 times 10 to the minus 5 is equal to x squared over 0.1875 minus x. If I do my quadratic, I find that x equals 1.828 times 10 to the minus 3 molar. And this is equal to the hydronium ion concentration. So the pH is equal to minus log of the concentration of H3O plus. And so the pH is equal to 2.74. Okay, so something to remember with these problems. this portion of the problem, this is the same as the method that you learned in chapter 16, because we have a weak acid in solution. The only thing that we are adding on to it is the stoichiometry, which we learned in chapter 4. And so before we can figure out what method of finding the pH to apply, we have to find what is in solution and then apply the tool for finding the pH of that solution. Okay, so in the next video, we're going to talk through what are called buffers and how to find another way of finding the pH of the solution when we have something different in our mixture. So I'm going to zoom out so that you have a full view of this problem. And I hope to see you in the next video.